With videos in data science. Actually, part 1 and part 2 of this particular video was done earlier. So now we are going to talk about sine wave model forecasting using LSTM. As you can see on the screen, there was a sine wave model already generated, and we are going to test this in this video. So the objective of this program is to demonstrate the use of pre-trained LSTM neural network model to make predictions on a set of randomly generated test dataset, including noise, to showcase the model's predictive capabilities. So the complete program is going to look like this. As we discussed in earlier videos also, it's a NumPy, matplotlib for plotting, math, random, pandas, etc. required. Keras is also required. Now, the first thing, you have already built a model and put it in an H5 format. Now we have to load that model. So the lines which are used to load that model is simply load model, the H5 file. Once after loading it, you can see that actually the model is now loaded, and also you should load the CST, original sine wave CSV file, also to use this. So second part is generate random sine wave data points. So the idea is you have a good model, sine wave model. Now you are going to create a noisy sine wave, and we would like to see whether it forecasts as a right sine wave. So you have a X-test. X-test is the array where you are going to store the new noisy sine wave waveform. How do you generate a noisy sine wave? You take a random number, and add it to the real sine wave, n into 3, where n is a noise, and append each data into 100 points of data into X-test. This is what you have created, a noisy sine wave. Now after that, you just plot it and see how it looks like. Whatever plot you have got here is coming from these lines. Now comes to the data pre-processing. Like we did earlier, in this particular case you have the test data, and you have to now create a window of 10, and you are going to in fact create a test dataset, which is a noisy dataset with a proper data sequence. So what you're doing is, like, you are creating a new array xin, and you are reshaping that. This is what was the process which was going on earlier also. And the first prediction is done, xpred is equal to new model dot predict xin, and xin, what it contains? A noisy sine wave. You will see that after predicting it, it was a very highly noisy, and it almost removes the noise and brings back something. And since it was very highly noisy, it could bring back still almost like a sine wave. Whereas if you do a second prediction means it will be better. So purpose of performing second prediction is to simulate the model's ability to predict multiple future values in a time series. It shows the model's capability to generate a sequence of predictions and allow users to observe how the predicted values evolve over time. So this is an approach in time series forecasting, especially when dealing with the dynamic patterns and sequences where each prediction can influence subsequent ones. So it provides a visual representation of how well the model captures and extends patterns, extending the patterns in the data beyond a single time step. So you can see that the X-test is passed inside, and you are predicting. So the xin will be now the new noisy sine data. Xpred will be the predicted values. So the predicted second prediction again gives a much more cleaner sine wave from such a noisy sine wave. So he is able to forecast quite well and predict quite well. So wait for the next videos in LSTM, and all the description of this program is given below.